This is a mock-up of Nikola Tesla's Analogue dynamic balancing machine. We've just got a mock-up here of a 5-inch rotor, and that's just a 3D printed PLA disc and star washer. Just for visualization, so the biggest silicon carbide carborundum grinding wheel that Dremel make is this one, and it's not really got a very big diameter. They do make an aluminium oxide similar to this, but it's orange, and it's an inch. I think this one's 34mm. This has got a 1/4 inch shank. The Dremel ones have got an 1/8 inch shank, so if you're going to use anything this size, you're going to have to machine it down to 30mm and take it from 1/4 inch down to 1/8 inch, which is about 3.2mm. I've measured a lot of the Dremel ones. They're about 3.1 to about 3.15, so anything around there is going to work with this shank. And yeah, so you can get these from a company called mcsdirect.co.uk. It's about £2.50. They do pink ones and blue ones. This one is rated to about 30,500 RPM. So you've got to be careful with all these grinding wheels. You check what the top speed is and know what the speeds of the Dremel are. I think the top speed of this one's about 20,000. If it was the inch aluminium oxide one, I'll have to double check on the figure for this one actually. But yeah, so as you can see, the problem with this mock-up is we have a collision problem here. So the grinding wheel cannot reach, even with this one, let's say it's about there. You've got a bit of reach, but you can't go across the whole. If this rotor was this wide, you couldn't go across the whole face. So this leaves a little bit of a redesign of this bracket, because at the moment there's just too much exposed here. I mean, ideally we'd want none of this here, and it would be able to move at least another, let's say 10 to 12mm in that direction, and adding one of these gives a little bit longer reach. Again, about another 10, 15mm, something like that. So how are we gonna get how are we going to solve that problem? Well, it turns out that Dremel actually make something called a multi-vice, and they've already put a lot of R&D into a piece that holds this, because this is actually, there's a screw thread on the Dremels here, that's on most of the models. And they've designed this multi-vice so it can hold the Dremel like that, and you can position it. So we've bought one of them, we're waiting for it to arrive. The plan is to fix that to the XY cross slide. Not too sure how that's going to look yet because we haven't received it, so we don't know what we've got to work with. And we believe that that is going to allow lots of different positions for putting the Dremel, and it's going to get rid of a lot of this problem here, so it can't move. It's going to be a lot more versatile. Whether it'll be stiff enough, I don't know, but I'd imagine that Dremel have put a lot of money into R&D of this part because it works across pretty much their whole range and a lot of their older range. So the plan is really to see how big a rotor can we go to in diameter and width using a Dremel and off-the-shelf bits without really engineering anything new. And then the next step would be to upgrade the Dremel to a bench grinder and a 6-inch grinding wheel, which is going to provide a completely different scenario, and then see how much further we can push a 6-inch grinding wheel. I mean, what's the biggest rotor we can do with that? So perhaps even the 6-inch rotor can do, the 6-inch grinding wheel can do an 800mm rotor, which is about 31.5 inches. If it can balance that, then, well, yeah, maybe it can balance even bigger, but do we want to make any bigger? So, yeah, it's coming along. Just thought I'd give you a progress update and let you know where we are. We need to try some M8 T-slots because none of these actually fit, unfortunately. The M10 ones will fit here with a little bit ground off the sides, but I don't think really they should need anything doing to them. I think we should be able to buy something that doesn't need any work. So interesting to see what these Dremel accessories will add to the mix. Here is an aluminium oxide 1-inch grinding wheel with a 3.2mm shank for a Dremel. That's the biggest grinding wheel that they do. On the packet, it recommends for stainless steel, copper, gold, aluminium, and yeah, that's for grinding. And then the silicon carbide one, which is this one. That's 19.8mm. Both of them have got a max of 20,000 RPM, and this one is actually silicon carbide is carborundum, which is what Tesla actually recommends in the patent. Not sure if aluminium oxide even existed back then. I'm guessing not, but I think this one would be more suitable to what we want to do. A, because it's got a larger diameter, and B, because the formula of the grip is more suited to the application. But some empirical data will answer that. But these are literally the only two larger diameter grinding wheels that Dremel actually make themselves, and yeah, so we're going to be testing them with the Apparatus. We've also bought this accessory to try, which is a light, so you can put a light onto the workpiece. So we'll give that a go, see what that's like. Just another mock-up. Got the 1-inch aluminium oxide grinding wheel, which is the biggest diameter one that Dremel make, with an 1/8-inch shank. Screwed the Dremel piece on here instead of the 3D printed bit, and it doesn't quite fit there, but it's okay. Just for this mock-up. Again, we've got the same problem. There'll be a collision if we wind here. There's going to be a collision. So for this 5-inch rotor, if we wanted to balance that, we couldn't get this A near the rotor or B across the face. So definitely going to have to be some changes to get anywhere near that. So we'll see what we can come up with. And the next thing that we can try is we'll move that one away, and yeah, we'll stack these up. So it's definitely looking better on a distance. We need a bit of a higher tower, so I'm just going to get some more blocks. So if the rotor was being spun using compressed air, which can be heated or not, then the Dremel will be switched on. Just put it on a low speed, and then using the X and Y controls to be brought into contact with the rotor. And grinding can be effective by moving the grinding wheel across the face. I think that basically demonstrates how grinding can be affected using the Apparatus. Once we've got it all properly bolted down, we can actually start grinding some rotors and some other stuff. See what else we can do with the Apparatus. So we've got this Dremel accessory. It's a torch to highlight the workpiece, which if we can fit onto the build, might be handy. So we'll see if that can be incorporated. One thing's for certain is a bigger diameter grinding wheel is definitely advantageous for getting at any rotor. So I'm pretty sure on MCS Direct's website. I've seen a 2-inch, one of these. Now the RPM, the max RPM is going to be a bit lower, but that doesn't matter. The only downside to these is they've got a 1/4 drive shank, whereas the Dremel's an 1/8 shank, so you need to shave down 30mm on a lathe or a grinder, and yeah, then you'd be able to use a 2-inch grinding wheel on here, which will definitely give a better range, so I'll have to get one of those and give it a try. Got these 2 1/4-inch shank grinding wheels. I've ordered some in pink as well. The advantage over this, the advantage of this one over this one is that the width of the actual grinding wheel itself is 3/8 of an inch, whereas I believe this one's a quarter of an inch. So this one's actually going to have a little bit more range on the width of the rotor. So I'm pretty sure I've seen wider than this. So I'll be looking at that. But I know this one's got, I think, a 38,000 max RPM limit, which is higher than the Dremel goes. The Dremel only goes to 35,000. So we're looking for other 1/4-inch grinding wheels that have got wider and bigger diameter wheels, so we get more range with the Dremel. We want to max out the Dremel and what the Dremel can do before we start going into adding a bench grinder. So yeah, just thought that was interesting. They fit in these grooves, so you can position different stuff wherever you want it. This particular one's an M10, I think, by 30. You can get these off eBay, and I'm sure these T-bolts, or T-heads is the other name, can be purchased elsewhere. I've seen them in stainless, and yeah, they're going to probably be available in higher tensile as well. Yeah, so you'll be able to position all sorts of stuff all over this bed, and they fit for this one as well. So they only fit one way. They won't go that way. 90-degree turn. They'll go in there. So that's handy. If they fit both. They fit both things. So okay, for those, I'm trying to make this apparatus as many off-the-shelf parts as possible, so anyone wanting to replicate it can just literally buy their own cross slide. Doesn't have to be this one. They could buy their own bed. Doesn't have to be this one. They can buy any of the Dremels that have got the thread in there, which is pretty much all of them, and the old ones. Trying to come up with something so we can get rid of that and this, which might be the Dremel multi-voice. We're just waiting to receive that, and trying to find some off-the-shelf grinding wheels that will work. We might have to just take the shank down from 1/4 inch to 1/8 of an inch. And yeah, the more off-the-shelf parts, the better, really, for everyone. Seeing as the cheapest small parts balance is about £6,000. If we can put this together for less than 1,000 or thereabouts, then that would be ideal, and lots more people can get involved in balancing many things. Thanks for listening, guys.